Welcome everyone. This is Bill Lester here again. In this video and the next one, we're going to talk a little bit about soils and plant nutrition. Both of these are very important topics. Many times there's a lot of plants that only grow well in a certain type of soil. So if they're not growing well, you don't have to look any further than the type of soil they're growing in. And plant nutrition, it's a very important topic. Master gardeners normally make fertilizer recommendations to people, and you'll learn that many plants really aren't very particular about their nutrients. They need very few additional nutrients. But when we move on to the modules on citrus and palm trees, you'll learn that a lot of plants are very fussy about their nutrients, and you need to have a good basic understanding of what types of nutrients different plants need so that you'll understand what those plants need to do well. So what is the soil? Soil is a natural body comprised of solids, liquids, and gas that occur on the land surface. So there's a lot of different characteristics of soil that we're going to cover: soil profile, particle size and density, the structure of the grain and the texture. Pore space is very important, especially when we get a hurricane, tropical storm, or a lot of rains. You'll learn that every type of soil has good parts and bad parts. Most people in Hernando County have very sandy soil, which is good when it rains 24 inches in 12 hours because it's going to drain very quickly. The problem is if you're trying to grow plants in a very sandy soil and it's a very sunny day, your plants are going to dry out very quickly. So there's good parts and bad parts of it. We're going to cover about what pH is and the importance of pH with soils and with growing plants, and also fertility in the second part of this video series. So soil contains the parent material. It's the natural original rock that the soil was created from. Climate is very important. Topography is important. Biological factors are extremely important. You'd be amazed at how many different living organisms live in the soil, and all of them play a very important part of breaking down components, recycling nutrients, making nutrients available in a form that plants can take up, and of course time. Soil forms over a very, very long period of time. So in an ideal soil, you will have 25% water, 25% air, about 45% of the natural mineral component, and then 5% organic matter. Now, as we're going to learn in a little bit, in Central Florida, the organic matter component can be much smaller than 5%. In a very heavy soil with a lot of clay, you may end up with a lot more than 25% water and a lot less than 25% air. In a very sandy soil that drains very quickly, you may end up with very, very little water in it. So all these different soils are going to have different components to it, but in an ideal soil situation, you're going to have 1/4 air, 1/4 water, and about half mineral component. So in Florida, believe it or not, we have a large number of different types of soil in the state. The soils, of course, way up in the Panhandle are very different from Central Florida, which is very different from South Florida. But in the Florida plateau, most of our soils are based generally on limestone. That was the natural parent material that our soils were either formed from or sitting on top of. Now, limestone underneath the ground causes things like sinkholes and springs, and it's the reason behind the aquifer that we have where we get all of our drinking water from. Why that is the limestone bedrock underneath us. Over a very long period of time, tens of thousands of years, water will bit by bit wear away that limestone. That's why the water here in Hernando County has so much lime in it, is because the water is constantly wearing away the limestone. It causes large holes and craters underneath the ground, which is where water goes and is stored. If there isn't enough water, or if the surface of the ground above it becomes too thin, it caves in and we have a sinkhole. And then over time, the water underneath the ground can pop up, and then we have something like Weeki Springs. All those different features that are associated with limestone bedrock are called karst features or karst topography. And that's the reason behind the sinkholes, the springs, and so many other features of Florida. Different types of soil particles come in different sizes. That's what determines the name that we associate with it. Relatively large soil particles are considered to be sand. As you can see, that's 0.05 all the way up to 2 millimeters. Very, very small soil particles are clays. They're extremely small, and then between the two is silt. So this has a lot of effect on how well the soil drains water and how well plants will grow in it. And like you'll learn with soils, every different type of soil has pluses and minuses. Sand drains very well, which is a good thing sometimes, but doesn't hold water very well. Clay, on the other extreme end, holds water extremely well, but it doesn't drain very well. Plants tend to do best in a soil that's kind of between the two, with a large percentage of organic matter, which we're going to cover in just a few slides here. But the name that we associate with the mineral is based on the exact particle size of it. So it's generally the particle size that determines the size of the pores in the soil, which determines exactly how well that soil drains. So in a very sandy soil, you have large openings, large tunnels, large empty spaces between the particles that are called macropores. That results in very good drainage, but on the other hand, very low water holding capacity. Clays, on the other hand, are made up of such small particles they tend to pack together very well, and they have very, very small number of pores in the soil, so they have micropores, and that results in poor drainage. But on the other hand, clay-dominated soils hold a lot of water, so they won't dry out as quickly. Like I mentioned earlier, we have a lot of different types of soils here in Florida, and soils are classified because humans like to divide things up, assign names to them, put them in groups. So there is an entire science dedicated just to soils, where soils are broken up and given different names by the type of soil it is. So some examples of really poorly drained soils that we have here in Florida would be histosols, which are swamps and marshes, spodosols, which are flatwoods, urban soils. Very well drained ones are ultisols or alphasols. And then excessively drained, extremely sandy soils are entasols, which in historical time period are very, very young soils. I mean, they may still be a couple million years old, but in the large term, they're very younger soils. So you really don't need to learn the names of the different soil types, but be aware that there is an entire system for soils where different types of soils are given different names. So pH. pH can be a kind of difficult concept to wrap your mind around. pH is the measure of the concentration of the free hydrogen or hydroxyl ions that are in a liquid. So it's always a liquid that's having its pH measured. So when we measure the pH of a soil, we're not really measuring the pH of the granules of sand or clay or silt. What we're measuring is the pH of the free water that's surrounding those grains of sand or clays. So here's a little example here of the pH of some different commonly found liquids. You see the pH scale goes all the way from 0 to 14. At the low end, from 0 to 7 is considered acidic. From 7 up to 14, the pH is alkaline. So here's some different things. For example, battery acid is extremely acidic, so that's going to be a very, very low pH. Gastric fluid, lemon juice, they're all very acidic, very low pH. Other things at the other end with a very high pH would be household bleach, household lye, ammonia, milk of magnesia. So obviously if the scale goes from 0 to 14, 7 is right in the center of that. So something with a pH of 7 is not considered acidic or alkaline, it's considered neutral, right in the middle. So 100% perfectly freshly distilled water is neutral with a pH of 7. So this is very important when growing plants because the pH of the soil, or technically the pH of the water component of the soil, is very important. pH can determine the form that different nutrients take, whether they're locked together with other ions into a different um, mineral, or whether they're in a form that plants can take up. Some plants grow very, very well in acidic soils. Other plants do very well in alkaline soils. Other plants do well over a very wide range of pHs. Other ones are very, very fussy, so they have to be grown in a soil with a very specific pH. So let's look over a couple different examples of plants and the pHs that they prefer. Here's some different plants that you'd find in the landscape and the different soil pHs that they're going to grow the best at. There's several plants where you have to grow them in a very acidic soil. You see azaleas, blueberries, and camellias. They all like an acid soil. Azaleas prefer 4.5 to 6.0, so that's obviously below 7. 4.5 is a pretty acidic soil. Blueberries like it a little bit more acidic at 4.0 to 5.5. Camellias like it acidic. Some plants like citrus likes it close to neutral. Most vegetables and flowers are going to like it just slightly acidic. Centipede grass likes a fairly acidic soil. St. Augustine, this graph says 6 to 6.5. St. Augustine can grow well at an even wider range than that. It's pretty forgiving with pH. Roses 5.5 to 6.5. Bahia grass has to grow at a fairly acidic soil pH. So what does this mean to you, to your landscape, to a normal gardener? You can see almost every plant likes to grow at least slightly acidic soil pH. So you rarely see plants that prefer something at 7 or above 7. Most plants are going to prefer at least a little bit below 7, which is perfectly neutral. Certain plants like Bahia grass, if it prefers or requires a soil pH of 5.5, if you try growing that and your soil pH was 7.5 or 8, it's not going to do very well. A lot of people make the mistake, they think, oh, blueberries grow great here in Hernando County. I'm going to get some blueberries, I'm going to plant them, and they have no idea what the soil pH is. Their soil pH turns out to be 7 or 7.5. Their blueberries will die a very quick death. A lot of plants, if they have a specific pH requirement, that pH requirement needs to be met, otherwise the plant will either suffer or just not produce very well or die very quickly. Different lists of pH ranges, ideal pH ranges for different plants are very easy to find online. University of Florida has a lot of good reference material about that. So whatever plant you're trying to grow, to find what pH is going to do best at is very easy information to find. So what other kind of effects does soil pH have on a plant's growth and health? pH plays a very important part on nutrient availability. This is a very common graph right here. You guys are going to see this quite a few times that show how available any given nutrient is over a range of pHs. So if you look at this graph here, on the far left-hand side is a pH of 5.0, which is pretty acidic. On the right-hand side is pH of 9.0, which is very alkaline. So if you're looking at how available any nutrient is at a certain pH, you can go by how wide the line is. So starting at the top, nitrogen is freely available at a very, very wide range of pHs. pH generally does not tie up nitrogen or cause any problems with nitrogen. Phosphorus, which is another important plant nutrient, is very pH sensitive. This graph doesn't really make it very clear, but phosphorus is only freely available for plants to be able to use at a very narrow range of generally between 6.5 and 7. So if your soil pH is very high or very low, even though you may have plenty of phosphorus in the soil, it's going to be tied up with another mineral and it won't be available to your plants. If your pH is very low, the phosphorus will be tied up with iron, And at a very high pH, the phosphorus will be tied up in aluminum. So even if it's present, the plant cannot take it up. So it's very important that you maintain close to the ideal pH. Potassium is very forgiving over a very wide range of pHs. Same with calcium and sulfur. When we get down to some of the different micronutrients, iron, manganese, boron, copper, and zinc, all of which we're going to discuss at more length in a little bit, you'll notice that they're very, very available at very acidic soil pHs, but not very available at all. The width of the line gets very narrow at higher pHs. So with some micronutrients, you can have a problem if you're trying to grow citrus and your pH is very, very low. If you have a good amount of copper in the soil, let's say you've been using liquid copper as a fungicide, you may have a lot of accumulated copper in the soil. It can rise to levels where it's toxic to the citrus. At the other end, if you're trying to grow plants in, let's say, your flower bed or vegetable garden, the pH is 7, 7.5, or a little bit above, you're probably going to have a deficiency in some of these different micronutrients. Even if you have plenty of it available in the soil, it may be present, but it's just not available for your plants to be able to take up. pH also has an effect on the microbial activity in the soil. Soils with either very, very high pH or very, very low pH are not going to be very friendly towards soil microbes, which are very, very important for recycling nutrients and breaking down organic matter. So it's very important that you learn what pH the plant you're trying to grow requires and try your best to meet those pH requirements. So if you get a soil test and you find out that your pH is really low or your pH is really high, what can you do? I mean, surely there's something that we can add to the soil to help fix that situation. Yes and no. To a certain extent, you can adjust your soil pH. I'm sure a lot of you are familiar with lime, common garden lime. If you get a soil test and your soil is very acidic and you want to raise that pH, you can add lime, which usually contains calcium carbonate. What this does is it neutralizes the acidity and helps supply calcium to the soil and the plants also. If your soil pH is very high, which is an issue that we have in a lot of parts of the county, not a whole lot you could do to bring that soil pH down. If you're trying to grow some kind of annual crop, let's say you have a flower garden where you're growing annual flowers, you have a vegetable garden and you want to bring that pH down a little bit, you can use garden sulfur because sulfur is acidic. But when you add garden sulfur, you have to be very careful to use only a small amount, and it will lower the soil pH, but temporarily, only for a few months at maximum. So if you're trying to lower soil pH to benefit a tree, a palm tree, hedge bushes, some kind of perennial that's going to be growing in your yard for a very long time, there's really nothing practical that you could do to lower the soil pH. If you're having an issue with a lawn where the soil pH is too high for the type of grass you're trying to grow, basically you're kind of stuck with the soil pH that you have naturally. There's very little that you can do to lower that pH. And let me make mention of a lot of people moved to Central Florida from up north, and for some reason they grew up where every fall they put down lime. I think in some northern states, I'm not sure exactly why they do it, but they put down lime every fall. So they moved to Florida and their soil has a high pH and they put down lime every fall. Well, they're probably just making their problem even worse. You need to advise people, don't ever put down lime unless you get a soil test done first and that you know for a fact that you need it, because obviously if you have a naturally high pH soil and you go out there and just throw down lime thinking that you're going to benefit your plants, you're only going to make the problem worse. You would be amazed at the number of living things in a healthy soil. Here are just a couple different examples of things that you're going to find in a soil. Upper left-hand side, we have earthworms. Top center, bacteria. Top right-hand side, that's a nematode that we're going to cover in an upcoming module. Lower right-hand corner, a plasmodium. All kinds of different single-cell organisms. You have a centipede, bottom left-hand corner, fungi. You have a huge number of different living organisms in a healthy soil, all of which play a very important part in maintaining a healthy soil and healthy plants. Now, sure, your soil will probably have some bad bacteria and bad fungi in it that are going to cause plant problems. You may have immature beetle larvae, other insects that are going to, chew on your plant's roots and cause problems also. But something that really helps is it maintaining a healthy soil and a healthy mix and healthy populations of everything. And um, the good guys in your soil are going to help keep the bad guys under control. Something that really helps with this is soil organic matter. If you remember from the very beginning of the presentation, I covered that in an ideal soil, you're going to have about 25% water, 25% air, 45% mineral, and 5% organic matter. The problem is here in Central Florida, you're lucky to have 1% organic matter. Many soils have even less than that. And all you have to do is just go outside and start digging through your soil, put your hands down, pull it up. You'll see sand, but you won't see any organic matter, compost, living biomass, partly decomposed plants, animals, microorganisms. It's just not there. So to create an ideal garden environment, an ideal vegetable garden, a healthy environment for plants to grow in, we need to add organic matter. It's not going to be there naturally. So what organic matter is, it's the remains of plants, animals, and microorganisms, all in different various stages of decomposition. So this organic matter can help do a lot of different positive things for your soil. Like I mentioned earlier, clay soils tend to be very heavy, packed together, and don't drain very well. If you add a lot of organic matter to them, it will help loosen up that clay and improve the drainage. If you have a very sandy soil, what organic matter does is it helps to knit the sand particles together into smaller structures. It holds nutrients much better, helps hold water much better, helps to create an ideal soil structure. So organic matter is pretty close to a silver bullet. I mean, it won't solve all your problems, but for a very, very sandy soil, it's necessary to add organic matter. Now, a term that you may have heard before, humus. When you take organic matter, for anybody who has a compost bin or has ever made compost, you make a large pile of the different ingredients, and then you add a little bit of water, use a little bit of patience, time is your friend. When that material breaks down, it's only going to be about half the size of what it was. When it breaks down a little bit further, the organic matter gets to a point where it's a fairly stable structure. That's called humus. That's the organic matter that's well broken down. It will still break down further, but very, very slowly, because organic matter such as leaves, pine needles, grass clippings breaks down very quickly at first, and then it becomes more stable in the soil and lasts a little bit longer. So a few other benefits of organic matter, like I said, it helps condition the soil, improves the tilth, helps hold water, helps hold nutrients much better. Different types of soil have something that's called a cation exchange capacity, and that's the chemical ability of that type of soil to hold on to nutrient ions. At one end, sand is the very, very worst at holding on to nutrients. So if you're gardening in pure sand and you throw down fertilizer, the sand will not hold on to the nutrient ions very long. Either the plant needs to take up those ions pretty quickly, or the nutrients are going to wash away. They're going to end up in the groundwater. Different types of clay hold on to nutrients very well, but what holds on to nutrients the absolute best is organic matter. So if you use a lot more organic matter in your garden, on your lawn, the organic matter will help hold on to the nutrients until the plant's roots can stretch and reach that little piece of organic matter with nutrients and take the nutrients off of it and use it to their advantage. Organic matter helps to provide chemical buffering. It helps to stop the pH from swinging maybe high and low. It does help to balance out the pH. So I mentioned earlier, if your yard or your garden has a very high pH, there's very few things that you could do to it. One thing that you could do to it is add organic matter, because as that breaks down, it creates organic acids. Remember, acids are a very low pH. So creating organic acids in a high pH soil will bit by bit help to pull that pH down a little bit. Um, Organic matter is great for microbes and microbiological activity. The bacteria and fungi in the soil actually eat the organic matter. They consume it, they use it for energy, then they help convert it and break it down even further into the nutrient ions that plants can actually take up and use. Organic matter in the form of compost will actually help to add nutrients. Using a lot of compost that's made from a wide variety of different materials will provide a lot of micronutrients to your garden. And like I mentioned, the organic acids that organic amendments help to create will help to break different minerals into usable nutrients and will help to lower the pH ever so slightly. I mentioned CEC, or cation exchange capacity, earlier. This is extremely important in very, very sandy soils. At least 90% of the nutrient holding capacity in South Florida sandy soils for commercial growers comes from humus, or organic matter. Like I mentioned, the organic matter actually provides energy for the soil microorganisms. It is a food source. They consume the carbon atoms that are contained in it, helps to hold the soil particles together, and does provide a certain amount of nitrogen, sulfur, phosphorus, a lot of other micronutrients. The one nutrient that's really difficult to get just from organic matter or compost is nitrogen. So even if you make compost, you add a lot to your garden, you're adding a lot of micronutrients to your plants, you're actually seeing benefits from it, you're probably going to have to at least add a little bit of additional nitrogen, because that is the one nutrient that's really tough to get from just organic matter. But you do get a certain amount of it, and it will help you reduce the amount of store-bought fertilizers you're going to have to be using. So that concludes part one. As always, if you have any questions, please feel free to contact me. Write your questions down and ask them in class. Chances are, if you're wondering about something, or if I didn't explain it very well, a lot of other people are wondering the same thing. So you need to be the one to step up and ask the question. Or feel free to email me. Go ahead and put any kind of questions or things you're curious about in the discussion section on the Canvas website also. Thank you.